So just one more video here. I'll show you the wiring and show you just a little bit more about how this thing works. As I mentioned before, little piston up here, little lobe cam goes around and runs this back and forth, and that's just so it can follow. This goes up and down, and that's pumping the piston. And this thing is a closed system inside this canister. That's why that canister is so thick. So it actually, you can see it just pulls right into the inside there. So when you cut this open, if you plan on using it as a refrigerator again, you need to weld this thing back closed completely, evacuate it, and then put new coolant in, which is all can be done pretty cheap because it holds like 1.5 ounces, I think, of coolant. You can use an R12 to R134A conversion, and for $6, you can get a little piercing port that you put on here that'll stay. Lets you put coolant into it. Matter of fact, you can use that if you got your home fridge needs coolant. But I've got one of those coming. And so you do that, you go buy a little can, or if you got a can of automotive 134A, and then you can borrow from AutoZone for free the tool to suction this thing out once you get it welded up. So you just hook that tool from Harbor Freight or from AutoZone up, suction this thing out, and then put in 1.5 ounces of coolant, and as long as you don't have any other holes in this thing, you're good. When you evacuate it, you can test, and if you got a hole, you can listen, you can find it, and you can solder that hole closed, by the way, too, if you need to fix something. But just to show you real quick, in case you wanted to play around with one of these things, I think you can just pull it out of there. I don't want to screw it up because I actually want to make it as a refrigerator too, but it's on a couple of spring mounts in there just to make it, real quiet. And then it's real simple electrically. It's got 3 plugs down here. Here's the 2 plugs, and one of these sides is a starting armature and one's a running armature. And all this thing does is start it off with both of them powered up, and then it switches to just the running armature. And this is kind of cool. This part can break, and it's probably cost you $1 somewhere. This is just a little overload sensor. And with mine, since it was frozen, that little overload sensor would kick it on and off. So you'd hear it click, click, click. And it wasn't the thermostat on this one. It was this thing getting too hot and shutting off. And this is on the common. And there's just 2 little pieces of metal in there. When it gets hot, it opens the circuit. So on the wiring itself, you can see on there's the 3 wires. And there's a common, a start, and a run. And the way you can tell which one's which, if you don't remember, is the highest resistance will be between the start and the run, and then you'll get a lower resistance between either the start or the run and the common. And then going between the common and the start, or the common and the run, you'll get a little bit lower resistance when you go from the common to the run than you do from the common to the start. And there's, because it's pumping in a little more oomph to chooch the thing when you're going into the start. So you got to figure out the wiring. That's all it is. And if you just need to start making it run to test it, you can actually just run common, and then you can just jumper start to run for a short period just to see if you can make it run. If you don't have the other wiring, just don't leave it that way for more than 1 second or 2 to see if it runs. Now, I will say I had to pull mine apart. It's a shame because I have to go back and recharge the coolant, all because it was stuck a little bit. There's an old tool, if you can find it from somewhere, that electricians and repairmen used to use back when they used to fix stuff and not just put new parts and everything. And it would actually reverse the direction of the motor momentarily. So we'd give it a shot of reverse, and when you shoot it in reverse, it would usually free the thing up. It had a little switch. You switch, shoots it in reverse, and then it would let it run forward. And most of the time, that would be enough to free them. So if you're lucky enough to find one of those, you could probably fix it without tearing it apart. But for me, it was more just a little project to see how the thing works. So hopefully that was helpful and give you some ideas what you can use this thing for. People say you can use them for air compressors, airbrush compressors. I even saw some stuff where people converted them to little gasoline powered engines. So have fun, find cool ways to use it. See ya.